Good morning, dear students. Today, in this video lecture, I am going to discuss Cannizaro reaction and electrophilic substitution in aromatic aldehyde and ketone. I have already discussed the aldol condensation. So you know aldol condensation, it is of two types, simple aldol and crossed aldol. So first of all, what is your Cannizaro reaction? Aldehydes having no alpha hydrogen atom, aldehydes having no alpha hydrogen atom, when reacts with aldehydes having no alpha hydrogen atom, when reacts with conc alkali, that is NaOH or KOH, then disproportionation takes place. That is one molecule of aldehyde is oxidized into the corresponding acid salt, while the another molecule of aldehyde is reduced to alcohol. So as you know, formaldehyde and benzaldehyde, they have no alpha hydrogen. So naturally, they will give your Cannizaro reaction. For example, if we have 2 mole of formaldehyde, when it reacts with conc alkali such as your conc KOH, then the 1 molecule of formaldehyde is reduced to methyl alcohol. However, the another molecule will be oxidized to your potassium formate. This is your methyl alcohol. Similarly, if we consider 2 mole of benzaldehyde, this is your benzaldehyde, when it is heated with your say conc KOH, then this will give 1 molecule is reduced to give your benzyl alcohol, while another molecule is oxidized to give potassium benzoate, that will give you potassium benzoate. So you can say this is your Cannizaro reaction. So this reaction is your Cannizaro reaction. This is your Cannizaro reaction. This reaction is your Cannizaro reaction. Now, similar to aldol, there may be crossed Cannizaro. Now, what is the meaning of crossed Cannizaro? Crossed Cannizaro means if we use formaldehyde and benzaldehyde, and then if we treat it with your conch, say NaOH, then what happens? This formaldehyde is oxidized to give sodium formate. This will give you the sodium formate, while the benzaldehyde is reduced to your benzyl alcohol. This will reduce to your benzyl alcohol. So why formaldehyde is oxidized to give sodium formate? Because in case of oxidation, we have to see the steric hindrance. This benzaldehyde, due to the bulkier phenyl group, it is preferred to reduce, but it will not be oxidized. So oxidation easier for your formaldehyde, so that it will give you sodium formate. So this is your Cannizaro reaction. Now next is electrophilic substitution. Next is your electrophilic substitution in aromatic aldehyde and ketone. For your information, both the aldehyde and the ketonic group, both the aldehyde and ketonic group are deactivating in nature. They are deactivating in nature. Therefore, they will deactivate. Therefore, they will deactivate the ring towards electrophilic substitution. They will deactivate the ring towards electrophilic substitution. So what will happen, as they will deactivate towards electrophilic substitution, so there will be no Friedel-Crafts reaction in this case. That is very important. Only there will be nitration, sulfonation, and up to some extent halogenation. Now it is meta-directing. It is your meta-directing. It means the substitution, the electrophilic substitution will take place at meta position only. Now let us see nitration. Say this is your benzaldehyde. This benzaldehyde, when heated with conch nitric acid and sulfuric acid, on meta position we have our nitro group. So on meta position we have our nitro group. So the product form is your 3-nitro benzaldehyde, or we can say meta-nitro benzaldehyde. Let us suppose sulfonation. What happens when there will be sulfonation? So in case of sulfonation, simply we use sulfuric acid, that is H2SO4. So in place of your nitro group, we have sulfonic acid group. Then it will be your 3-formyl. It is your 3-benzene sulfonic acid. This is your 3-formyl benzene sulfonic acid. Now in place of benzaldehyde, if we consider acetophenone. If we consider acetophenone, then this is your acetophenone. This is acetophenone. This acetophenone on nitration, that is with conc nitric acid and sulfuric acid, the product is your simply 3-nitroacetophenone, or you can say it is your meta-nitroacetophenone. This is your 3-nitroacetophenone, or it is called your meta-nitroacetophenone. इसी तरह से इनका सल्फोनेशन अगर आप करते हो, अगर इनकी सल्फोनेशन करोगे on heating with sulfuric acid, then your product will be, this is your COCH3 and this will be SO3H. तो अब आप इसका ये नाम कर सकते हो, because you know the IUPAC name of the compound. So this is your electrophilic substitution in your aromatic aldehyde and ketone. Similarly, there may be halogenation. I hope you can do it. If you treat it with bromine in the presence of FeBr3, you will get meta-bromo-benzaldehyde, and similarly, in case of acetophenone, you will get meta-bromo-acetophenone. I hope this is all about your aldehyde and ketone. From next class, I will start carboxylic acid. Thank you.